Hello, my name is Phil. Welcome to my YouTube channel, Mazatrol Tips and Tricks. In this video, I'm going to show you how to program our first part. This is our first workpiece example, and I'm going to show you how. This is a very simple workpiece example. I'm going to show you how to program it from the beginning to the end. First thing we're going to do is push the left button and go into Program, and then Program File. And then we're going to select a work number that is not listed up here in order to create a new program. So we're going to select work number 21. So go back to Program, push work number, workpiece number 21, input, and it couldn't find it in the memory, so it's asking if this is a new program, push the Program button. And now it's asking us Mazatrol or EIA program. We're going to choose a Mazatrol program. Workpiece material. This part is made out of aluminum, so we're going to select aluminum in a workpiece. Max outer diameter of workpiece is 3.2 inches, 3.25 inches. The inner diameter is 0. The workpiece length is 3 inches long. Max spindle limit. This is the G50 for the entire program. I don't want to run the chuck past 2,000 RPM, so I'm going to type in 2,000 and hit input. Finish allowance on X. This is the stock that's left by the roughing tools, so the finish tools can clean it up. I'm going to leave 10 thousandths on the diameter, so 0.01 input. Finish allowance on Z is going to be 5 thousandths, 0.005 input. Stock removal of work face. I'm not going to have any stock removal. I'm going to skim the part manually and set the Z0 on this program. Down arrow. First thing we're going to do is turn on the coolant, and that's 99% of the time what we're going to do for the first operation. So push the 3 arrows. Another menu comes up, push M code, and push coolant on, and then down arrow. So now we have another choice of icons. The first thing we're going to do is program this part, and it's bar stock. So we're going to select the bar option, and we're going to select bar out, the first one. The ones that are highlighted change the way the roughing tool and finish tool approaches the part. On the highlighted ones, the tool is fed down into it and feeds across. The ones that are not highlighted are open geometry, and the tool rapids down and feeds across. So we're going to select the open geometry. Cutting point on X is going to be our stock diameter of 3.25. And the cutting point on Z is 0. And what we're talking about is this is the shape we're going to be programming. The cutting point is here at the outside diameter and the face of the part. With Mazatrol, we always program from the face and work in toward the chuck. Surface speed for rough cut. This is what the roughing tools are going to use. Arrow over. Surface speed for finish cut, FV, that's finish velocity. This is the speed for the finish tools. Feed rate for revolution for rough cut. And the last one is the depth of cut. And if we arrow over to the first one, this auto button pops up. And if we push it, it auto-populates the feeds and speeds for bar out and with aluminum as our stock. Arrow over, gear number. This is the machine's transmission. If we leave gear number 0, the machine will automatically select the correct gear when it's roughing and finishing the part. As it is, this machine only has 1 gear anyway, so this field is really not used on this machine. Roughing tool number. This is the tool we're going to use to rough the part. If we push tool data, we're going to use tool 4, which is a general out, and it is a 95-degree angle, 80-degree insert. go back to program. 4, offset number 1. On this machine, it has 2 different offsets. Offset column number 1 and offset column number 2. If we leave the offset at 0, it will not pick up the wear offset, and it just goes by the geometry. So we need to make sure we at least put a 1 in there for the wear. Finish tool number is tool 4, offset number 1. So now it's given us a shape pattern, and we have 4 different choices for different geometry of the part. We have a linear, which is a horizontal or vertical line, a taper, which is an angled line. We have a convex radius, and we also have a concave radius. And over here where it says center, this tells us the center of the radius when we're programming with either the convex or the concave radius when we're calculating the endpoint. In this first example, we're going to create this horizontal line right here, and we're going to give it a 20 thousandths corner break at the front of the line. So we're going to say linear, 0.02 input. The final point on X is going to be 2 inches in diameter. The final point on Z is going to be 700 thousandths from the face. The final corner right here is unspecified, so we're going to leave it blank and use the tool's radius to create that corner. Surface finish roughness. This is the surface finish that is left by the finish tool. On this machine, we specify a surface roughness, and based on the insert's radius, it'll calculate the required surface finish that we want. A number 7 is slightly better than a 32 finish, so that's what I usually select. For a 31 thousandths radius insert, the feed rate will be 0.0039 inches per revolution. The next field is asking us for necking for an undercut, and we're not going to do that. Arrow over. The next area is asking us for an M code. We've already turned on the coolant throughout the program, so we don't need the M code here. So down arrow, right button, figure check. We got the figure left over from when we bored the jaws, so scale. Go back to program, right button, figure check. I turned off the store, so it redrew and rescaled it for me. I have the store button lit up. Now we can see what programming changes we make to the part. So go to program. And now we need to create this second angle here. The second feature is an angle. So go to taper. The starting corner is going to be 0. The starting point on X and the starting point on Z is right where we left off with the horizontal line. Now if we push continue, it'll auto-populate these 2 fields down into the starting points. So push continue. Now the final point on X for the taper is going to be 2.5 inches. The final point on Z is going to be 1.3 inches. Final corner, we're not going to have anything there. And then surface finish is 7, down arrow. Right button, figure check. And now we can see what we had previously, and we can see the angle created up there now. Go back to the program. We need to create this next horizontal line. So we're going to go linear. It doesn't have a starting corner on it. 2.5 inches is where we left off, and it's 1.75 inches back from the face. Surface finish is 7, right button, figure check. So now we see the program change each time we've looked at it. Let's go back to the program, and we need to break the corner up here another 20 thousandths, and in order to do that we need to create a horizontal line that's at least 20 thousandths long past the previous Z. So we go linear, 0.02 input. This is going to be our stock size, 3.25 input. The final point on Z is going to be 20 thousandths plus 2 thousandths, so the insert rolls over the chamfer. Otherwise it leaves a little sharp edge on the chamfer. So that dimension is going to be 1.772 input. Finish of 7, down arrow, shape N, and then we're done with the program. So N, right button, figure check. So now, if we want to redraw it, we push scale input, and that redraws the workpiece. And down here on the right-hand corner, this is a scale like on a map. 0 to 1.7 is shown right now. So if you take a ruler, that's 1.7 inches here, and it matches what's on the screen. If we make the scale a smaller number, it'll zoom this out. If we make it a larger number, it'll zoom it away. So we want to get more definition of what's going on, so we'll say scale. The cursor comes up. Now we can use our arrow keys to center up the image. Change the scale to something smaller like 0.5 input. And now we can see the corner chamfers on the part. But to really blow it up, we're going to change the scale one more time. Scale. Move the white cursor box over to the chamfer, and then type in 0.1. On this machine, 0.1 is the lowest scale that it goes to. And now we can see the chamfer clearly on the part. However, the rest of the part is off the screen, so we need to shrink the scale back down and recenter the screen. So scale 1, input. Move the arrow over, and I'll go back to 0.6 input. So now we have the image. So let's go and look at the toolpath. Store is lit up, so it's going to keep this scale for us. So left button, program, program check, and check continue. That done roughing it. Now the finished pass is coming up, and you see it rolled the insert over the top. Now if you look closely, there's a gap between the purple geometry and the white toolpath. The reason for that is because the white line is at the insert's tool nose radius. This is 31 thousandths, so that's exactly the distance the tool is offset. We're done programming the part, so now let's go and touch off the work face, and let's get this run for real. So go to position, go to hand control, and now I'm going to index to tool number 4. All right, tool 4's come up, and now we're going to skim the face of the part. So move the turret over to the workpiece. And we're going to skim the face of that part. All right, now that we have the workpiece in, we brought the tool up close to the part. We're going to turn on the spindle. We're going to give it about 1,000 RPM. And then turn it on. Come over here and we're going to skim the face of the part. All right, now we have the part faced off. We can back the X off, but leave the Z right where it's at. And now we got to set the work shift. All right, now that we've skimmed the work face, now we need to set the zero. So push the left button, go to Program, go to Program File, and arrow down to work number 21. Z offset teach, 0, input. Now we go to the left button and go to position, and you'll notice it's still on work number 20, which was our jaw boring program. We need to get this on program 21. So in order to do that, we go to Auto, go to work number 21, input. Now it's at 0. Now we go to the trace screen and move the tool, and we can see the tool come into the frame. So let's zoom it out a little bit so we can see more of the tool. So we'll go to the right button, scale, 1, input, then we'll push shape. So now we can see the turning tool. Now if we want to, we can also paint the part with the workpiece figure button. So when we're running the turning tool, we can actually watch simulated stock come off the part. So let's do that here. So that simulates our stock at 3.25 inches and also 3 inches long. Move the tool away from the face of the part. You can see what it's happening on the screen. All right, we're ready to roll. So we're going to go to Auto. The coolant button is on. And as a secondary check, we are on work number 21, and we did set the work shift. So now let's go and machine the part. Our part is done. It took 1 minute and 8 seconds to machine it. On this machine, we can simulate the program actually running without the machine running by going to Program and go into a simulation screen. And then we can go Simulation Ready and simulation start. then we speed up the simulation to 500% to speed up the graphics, but the actual calculated time is going to be close to the same. And if we push layout, the total cutting time it calculated is 1 minute and 11 seconds. Now if we go to the trace screen, it actually ran in 1 minute and 8 seconds. So it was only 3 seconds off of its predicted time. And that was our first piece, and we're done with the part. Hi, my name is Phil. Welcome to my YouTube channel, Mazatrol Tips and Tricks. In this video, we're going to go through our second demo piece. This is a doorknob or a trailer hitch ball sample piece. And it's a very simple geometry, but there's a couple of things that we need to watch for when we're machining it, and I'll get into that in the video. So let's get started. All right, let's get started programming on this part. This is the part we're working on next. This looks similar to a doorknob with a sphere on the front of it, a diameter, and a chamfer. So this is another easy part to program. So the first thing we're going to do, push the left button, go to Program File, and we're going to select a work number that is not listed up here in order to create a new program. So we're going to select work number 22. So let's go to Program, work number 22, Input, and it couldn't find it, and it's asking if it's a new program. If it is, push the Program button. Mazatrol or EIA, again, we're always going with Mazatrol. Workpiece material, this is aluminum. Max outer diameter of workpiece is the same as the previous program, 3.25 inches. The ID is 0. We don't have a hole in the stock. The workpiece length, this part's longer at 4.5 inches long. The max spindle RPM limit. This is the G50 for the entire program. We don't want to run the chuck past 2,000 RPM. Finish allowance on X. This is going to be the finish allowance the roughing tools leave for the finishers. I'm going to select 10 thousandths, which is 10 thousandths on the diameter for X, and then 0.003 thousandths on Z, because I'm going to be roughing the tool with a 55-degree diamond, and I want to leave less stock for the 35-degree diamond to finish. Stock removal of work face, I'm going to say 0.1 or 100 thousandths. And now the next thing we're going to do is turn on the coolant. Push the 3 arrows, M code, coolant on. Again, that's 99% of the time we're turning on the coolant as the first operation. So now we have that excess stock on the part, we need to face it off. So we're going to go with the edge process. And then surface speed for roughing and finishing, depth of cut. Again, we push the auto button. That auto populates our feeds and speeds for aluminum based on the edge process. If we want to kick the feed rate up, we can type in a number, 0.012 input. So now we have 12,000 feed rate for the rougher. We got to be very careful not to type in 0.120 as 120 thousandths per rev. The machine will not catch that mistake, and it will crash the insert into the part. Been there, done that a couple times, so be careful with changing the feed rates. We're going to rough it with tool number 4. Input, offset, always on this machine, offset number 1. We're not going to have a finish tool because it's a sphere, and we're going to finish that with the 35-degree diamond. So down arrow, starting point on X is the stock diameter, 3.25 input, The starting point on Z, the edge process programs to the right of 0. So we're going to program starting from 100 thousandths of the work face. Final point on X and final point on Z are both 0. And because we have 50 thousandths depth to cut, it's going to take 2 passes to clean off that face. Down arrow. Now we're going to start programming the sphere and the rest of this part. So we, again, starting with bar stock, and it's an open geometry, so we're going to go with out. Even though this area is closed, we're not starting right here, we're starting over here. The tools can wrap it down and feed into it. Cutting point on X, again, it's going to be 3.25, our stock size. Cutting point on Z is 0. And then we're going to do auto for the roughing and finish cuts. The roughing tool number, in this program, we're going to select a 55-degree diamond, which is tool number 1, and then offset 1. And then we're also going to select a 35-degree diamond for the finish tool. However, we're going to show you a reason why this can't be done in this process, but I'll get to that in a minute. So we're going to put it in tool 2, offset 1. So now the first thing we're going to do is we need to program a convex radius for this ball shape. And that's this one right here. It does not have a starting corner. The starting point on X, the starting point on Z are both 0. So this is the XY0 of the program, and this is where we're starting. The final point on X is going to be this diameter, 1.8 inches, and it's going to wrap all the way around to this line. 1.8. The final point on Z is right here, but it's not specified on the print. So we need to do some trigonometry to calculate that, and I'll show you how to do that with the machine. What is the radius of the sphere we're machining? It's a diameter of 2.5 inches. Half of that is 1.25 inches radius. 1.25, and then a surface finish again of 7. We forgot to put a question mark in here. So put a question mark because we don't know the end point. Down arrow. And then we're going to calculate the center of that radius. So push center, arc center X. It's centered on the workpiece around X0, so X is 0. Arc center Z is the distance from the end of the part to the center line of that radius, is 1.25 inches. Intersect position of start point. We already know the start point, so we can skip this field. Intersect position of final point. We have 4 choices up here: up, down, left, or right. So what it's asking us is from the center of this insert, where is this corner located? It's located in the up direction, but both of these points on that 1.8 inch diameter are located up from 0. But this one is located to the left of 0, and this one's located to the right. We want to select the left arrow so it calculates this furthest point for us. So left, push the right button, go calculate, and it calculated the Z position right there. If we go to the figure check screen, it has the previous job on here. Turn off the scale, the store, and go to program, and then figure check, and that redraws the shape. So now let's hit store and go back to the program. And now we need to program this horizontal line here and it has a starting corner of 100 thousandths, and the diameter is 1.8 inches. So linear, 0.1, push this button, and it changes the 100 thousandths chamfer into 100 thousandths radius. 1.8 inches. The final point on Z is going to be 3.25 inches from the front of the part, and it has a corner radius of 200 thousandths at the bottom of the line. 3.25 and radius 0.2 input. Surface roughness is 7. Down arrow. Right button, figure check. And now the program came across it, we need to break the corner at the top of the part. So we're not done programming just yet. So let's go back to the program. We need to create another horizontal line here, 100 thousandths long. So we say linear, 0.1 for the chamfer size. This is going to be our stock diameter, 3.25 inches. And then we need to make the final point on Z, 3.25 plus the 100 thousandths plus 2 thousandths to roll the insert up over the chamfer. Otherwise it leaves a little sharp edge on the chamfer. So 3.352, 3.352, 3.352 input. Surface finish is 7, down arrow, shape in. And then we're end with the program. Right button, figure check. And we're going to zoom in on the top half of this part. So we're going to say scale, move the arrows to where the center of the screen would be, and then put a smaller value in here like 1. And now we're programming from the, you can see the graphics from the center line up. And again, this geometry, we're not going to be able to rough out the entire geometry with the 55-degree diamond because this end of the ball is steeper than 30 degrees. But let's show that right now. So let's go to left button, let's go to program, program check, and then check continue. So the first tool roughs the part off. Here's the 55-degree diamond, roughing the nose of the part. And now it switches to tool 2, which is a 35-degree diamond, and the part's done. However, right here, it leaves an area that's not cut, an uncut area. Even though the 35-degree diamond can get in there, the 55 cannot, and the finishing tool will only cut an extra 10 thousandths on X and 3 thousandths on Z of whatever the roughing tool left, even though the finish tool can come down into it. So we're going to zoom this area up, scale, 0.1 input, push shape. We're going to center it up a little closer. Shape. All right, let's run the tool path again. Go to check continue. So right now the tools are off the screen, and we got to wait a bit until it starts roughing down the back side of the ball. All right, there's the roughing pass, and there's the finish pass taking off that 10 thousandths and 3 thousandths on Z. But you see the gap that's shown here, the distance from the center line of the insert's radius to the part is larger here than it is over here. And that means the tool could not come down and cut it. So in order to correct that, we're going to separate the roughing and finishing tools on a different process. So go to program, come down here, go into edit mode, arrow over to the finish tool, and we're going to put zeros in there to delete the finish tool. And we're going to copy the bar out roughing process down on its own line. So we're going to push the right menu button. We're going to go process copy, 2.2, that's the program we're working on, process number 3, and we just copied the process down. So now we need to arrow over, delete the roughing tool, and add a finish tool. And now we're going to rerun the part and show you the change. So program, check. We're going to erase the tool path, and then check continue. And again, it's roughing the nose of the part that we can't see on the screen right now. All right, here's the 55-degree diamond taking its roughing passes. And the 35-degree diamond does have the clearance, and that's what the 55 diamond could not do. So it's taken extra stock here on a finish pass. So that's how to override the machine to allow it to do this. But I didn't want to rough the whole part out with a 35-degree diamond. I wanted to rough it out with the 55, and then this little uncut area was not a big chip load on the finishing tool, so that's what I wanted to do there. All right, so let's zoom this out. Scale, 1, input, shape. So here's our workpiece shape. So what we need to do now is set the Z0 of our part. So let's go do that now. Tool 4 is already called up. So let's go over and touch the workpiece. All right, now we need to set our work shift. So let's bring the tool over to the face of the part. All right, we're gonna take off a 100,000, so that's plenty close for what we're doing now. So left button, program, program file, arrow down to program 22, push Z offset teach, and push 0.1 input. That calculated the work shift for this part. So now we go left button again and go to position. It's still on the previous program, and we need to call up work number 22. So go to auto, work number, 22, input. And it shows 100 thousandths positive on the screen. And now we can see the insert just up there. So let's zoom this out just a little bit. So one scale, 1.5, input. And now we can see the turning tool, push shape, and there's our workpiece shape. So right button, well, let's simulate the cutting time first. So let's go to left button, go to program, go to simulation, push the right button, simulation ready, simulation start. And our speed is at 500%. So now we're going to see the first two passes with the 80-degree diamond. And then here comes the 55-degree diamond roughing the part. also in the corner you can see our RPM is maxed out at 2,000 RPM for this program. Now it's switching to tool 2, and now it's finishing the ball and finishing the 1.8-inch diameter and the chamfer. And it's done. So let's go to the layout. The machine says it's going to take 2 minutes and 44 seconds to machine this part. So let's see how close that is now that we're going to machine it for real. So we're going to go to Trace, Auto, and we did call up the work shift, and we did set the Z0. So we are ready to roll. And the part is sticking out long enough from the jaws so we're not going to hit the jaws. We need to measure that just like a regular lathe. All right, here we go. Now it's switching to tool 1, which is the 55-degree diamond. Done roughing the part. Now switch to tool 2, 35-degree diamond, and run the finish pass. Right here where it takes a little bit extra stock than what it should have. All right, we are done. Cut time was 2 minutes and 38 seconds. And again on the layout screen, it said it was 2 minutes and 44 seconds. So it's 6 seconds off its time, and it's on the conservative side. So you can use this to actually estimate your program. All right, let's blow the part off. And we are done. And there's our finished workpiece. If you like what you see, subscribe to the channel and press the bell notification down at the bottom. Thanks and keep watching. Hi, my name is Phil. Welcome to my YouTube channel, Mazatrol Tips and Tricks. In this video, I'm going to show you how to machine this part I got right here. This is going to be our third demo piece, and it has turning, drilling, and milling in it. So let's get started programming this part. All right, here's our third part, what it looks like. So the first thing we're going to do is go to the program screen, the left button, go to program, program file, and we're going to select a work number that is not listed up here. So 23 is not up here, so we're going to choose that work number. So go back to program, push work number, type in 23 input, and it says program number was not found. If it's a new program, push this button. So push program. Now it's asking us Mazatrol or EIA, and we're going with Mazatrol on this. Workpiece material, we're going to choose aluminum. Maximum outside diameter of workpiece is 3.25 inches. Minimum diameter of workpiece is 0. It does not have a hole in it. Workpiece length is 3 inches long. Max spindle RPM limit is the G50 for the entire program. And I don't want to run the chuck past 2,000 RPM, so type in 2,000. Finish allowance on X. This is the stock that the roughers are going to leave for the finishers to clean up. I'm going to leave 10 thousandths on the diameter, so type in 0.01. Finish allowance on Z is 5 thousandths. And the stock removal of the work face. This is how much we're facing off the end of the part. In this case, 100 thousandths. Input. Now the first process we're going to do is turn on the coolant. For that, we need to push these 3 arrows, go over here to M code, and then coolant on, and then down arrow. So now the next thing we're going to do is face off the excess stock on our part. So we're going to push edge, and then again, the surface speed for rough cut, finish cut, and depth of cut, we can set automatically by pushing this button. The roughing tool number, we're going to use tool 4, which is our CNMG. Offset 1. Finish tool is tool 4, offset 1. Starting point on X is going to be our stock size of 3.25 input. Starting point on Z is going to be the 100 thousandths, 0.1. Final point on X and final point on Z are both 0. Surface roughness, we're going to choose number 7. What I didn't explain before is the lower numbers are a much coarser feed rate, and the higher numbers are a finer feed rate. 5, 6, and 7 are in the middle. A 7 is close to a 32 finish, a little finer than a 32. So I usually choose that. So down arrow. So we face the edge of the part off. So now what we need to do is describe this OD line right here that starts at 2 inches and it has 100 thousandths chamfer at the front of it. So we're machining bar stock. We're on the open geometry on the outside. Cutting point on X is 3.25. Cutting point on Z is 0. Surface speed for rough cut, again the auto comes up. Push that. If you wish to override it, you can do that. Roughing tool number, we're going to stay with tool 4, offset 1. Finish it with tool 4, offset 1. So now what we need to do is describe the shape. This is going to be linear. Starting corner is going to be the 100 thousandths, 0.1. Final point on X is going to be 2 inches. And the final point on Z is going to be 700 thousandths with 100 thousandths corner at the end of the line. So we push this radius button here first. That changes whatever value I type in into a radius. And you can see the yellow R pop up. Surface roughness is 7. down arrow. Now let's take a look at our shape. So right button, figure check. And we've got the 100,000ths coming off the face. And then we've got the diameter turned up to the stock size. If we push the store button, we can see what changes we have from now until we're done programming. So push store, go back to program. And now we need to make this horizontal line. Vertical lines, as you saw in this trace, are done automatically. So we need to focus on the horizontal line, and it has a 2.5 inch diameter with a 100,000ths radius at the front of it. So push linear, push radius, 0.1 input, final point on X is 2.5 input, and the final point on Z is going to be 1.75 inches with a 200,000ths radius at the end of the line. So radius, 0.2 input, surface roughness is 7, down arrow, right button, figure check. So this kept the image from before, and we can see that we added another linear line to the program. We're not done with it yet, so let's go back to program. We need to make one more linear line, and that's in order to chamfer this part right here. So go linear, starting corner is 100,000ths. Final point on X is going to be our stock diameter of 3.25. Final point on Z is going to be 1.75 plus the 100,000ths chamfer plus 2,000ths to roll the insert over the top of the radius. If we don't do that, it leaves a little tiny burr there. So 1.852 is our finish length. Surface roughness is 7, down arrow, shape end, right button, figure check. Now we can see the two chamfers on it, but let's blow this up a little bit to get more detail. So push the scale button, move the cursors up and over, and that white box will be the center of the screen when we change the scale. So let's give it a larger scale of like 1, enter, and that blew it up a little bit. So let's go back to program. So now what we need to do is we need to punch this hole in the center of the part. So this is the first menu that comes up, but there's not a drill on the first menu. So we push the 3 arrows. Here's the drill. Push that. And the drilling type has 4 different selections. 0 drilling feeds in and feeds out at the same feed rate, and it's useless on this machine. Number 1 pecking feeds in and then rapids out to the start. Rapids back in, feeds a little more, rapids back out as a chip clear. Number 2 pecking feeds in, rapids out a little bit and breaks the chip. And number 3 reamer feeds in and then feeds out at double the feed rate. Most of the time we're going to select number 1 pecking. Drill diameter, in this case, it's 0.69. Depth of first cut, again, we got an auto that comes up. So if we push that, it'll auto-populate our depth of cut, our feeds and speeds. So the first field is the depth of first cut. This is how much it's going to take when it first enters the workpiece. The second one is the decremental depth of cut. This is how much it's going to minus off of the depth of cut on each subsequent pass. And then finally, the minimum depth of cut. For deep holes, when this goes down, the minimum depth of cut is going to be 3 millimeters or 118 thousandths. Surface speed and the feed rate. The tool we're using is tool 13, offset 1, starting point on Z is going to be the front of the part. The final point on Z is going to be this hole depth of 1.57, and that goes to the end of the hole. On this older machine, it does not compensate for the drill point angle. The newer machines will go down to the major diameter of the drill, past the drill point. On this one, it does not. So type in 1.57 input, down arrow, and then right button, figure check. And now we've got a hole punched in the part. Again, you can see there is no angle shown on the hole. Go back to program. So now what we need to do is describe this bore size. The bore, it's a 900 thousandths bore with a 100 thousandths chamfer at the front of it. So again, we're using bar stock in this time, and it's still open geometry. Cutting point on X is going to be our drill diameter, 0.69. Cutting point on Z is 0. Again, surface speed for roughing, we push auto and it auto-populates our feeds and speeds for us. Roughing tool number is tool 12, offset 1. Finish tool is tool 12, offset 1. So the next thing we're going to do is the linear. Starting corner is 100 thousandths. Final point on X is 900. The final point on Z is going to be 1.3 inches. And the final corner, I forgot to put on the print, is a 50 thousandths radius at the bottom of the hole. So push radius 0.05 input. Surface roughness is 7. Down arrow. And now let's chamfer the hole going into the drill. So go linear. Let's give it a 20 thousandths chamfer. 0.69 for the hole size. And then we got to go this dimension, 1.3 plus 20 thousandths plus 2 thousandths to roll that insert over the chamfer. So 1.322 input, 7, down arrow, shape end, and then end. I haven't touched on the end process in the machine yet, but this is very powerful when you need to do multiple parts or switch between programs and etc. It's very useful for bar pulling. On this process, we just need to push end and leave everything 0. So let's go to the right button, figure check. And there's our bore. So now let's look at the tool path. So left button, go to program. That gets us out of edit mode. Push check, and then check continue. So what it's going to do is it's going to rough the face, then it's going to finish the face, and it's going to rough the OD. Toolpath erase to erase what the graphics. Here's the finish OD pass. Now it's going to drill the hole in the center. Now it's going to rough the bore. Toolpath erase. And now it's finishing the bore. So this is how it's programmed, but this is really not how I want to run this part. I would like to rough out the part and then run the finish tools. So I'll show you how to do that now. So go to layout, and if you notice, it's got R1, which is the coolant. R2 is the edge process. This is the roughing process. And then the finish process, and so on down the line. Now if we push rough priority on this screen, and then push the input button, notice how it reorganizes all roughing processes up front, and then finish processes at the end. And this is fine for how it's programmed, but to eliminate one tool change, I want to move this finish bar in process above the finished turning process. So to do that, move your arrows down, and it's going to insert a line above where the cursor is. So go move, process to insert. It's going to be a finish process, number 5, input. And now if you look, we're roughing it with tool 4, drilling it with 13, roughing it with tool 12, finishing it with tool 12, and then come back with the tool 4 to finish the face and finish the OD. You got to be careful on this screen because you can actually put the finish tools above the roughing tools and crash the part. So when you play with the layout, you got to be wary of that issue. The newer machines have a protection against that. On this one, because you're doing it manually, it'll allow you to do that. So let's go back to the program. Check. Toolpath erase. And then check continue. Now it's roughing the outside. Now it's changing tools to drill it. Rough the bore. Toolpath erase. Finish the bore. Finish the face. And now finish the OD of the profile, and it's done. So now from here, what we need to do is set the work shift. So we're going to come over and set the Z0 for this program. All right, we're ready to set the work shift. So come over here to manual. Come over to the face of the part. And let's turn the spindle on, like 300 RPM. There we go. All right, we're touching the face and we easily cut off 100 thousandths. So stop the spindle. Come over here and go to program. Go to program file. Arrow down. Arrow over to the Z offset. We're going to teach it. So push Z offset teach. 0.1, we're 100 thousandths in front of our 0 because this is the rough stock we're machining off. Hit input, and now we've taught Z. So now let's go to the position screen, and we're in program number 1 right now. So that's why the Z is not at 100 thousandths. So push auto, push work number, 23, input, and now we're at 100 thousandths. We, on the run side, we're on program 23. So let's go to the trace screen. So left button, trace. And now we can see our turning tool just like it is on the part. So now what we need to do is go to auto, turn on the coolant in auto, not in manual. And then let's hit cycle start and run this part. Making its 2 roughing passes. comes the drill. And we're done drilling the part. Bring up the boring bar. All right, done roughing it. Now it's the finished pass of the boring bar. Now it's going to come up with tool 4. So right now it's cutting a little bit of air before it cuts the part. In later videos I'll show you a trick to get rid of that. But for this video, it's fine. And we are done. 2 minutes and 56 seconds. All right, now in this case, I want to show you guys how to rerun a process in order to dial in the part. So let's say the OD was 2 thousandths bigger than it should have been. First thing we're going to do is going to go to the wear screen. So we're going to push the left button, go tool set, and then we're going to arrow down to wear offset number 1 in X, and we're going to go minus 0.002 input. So this is going to take 2 thousandths off on the diameter on tool 4. So now what we need to do is go back and let's go to the program, to the layout screen, and we want to run the last process, the F3, the finish 3 process. So what we're going to do is going to push this button down here, single process, go to position, and it's asking us which process do you want to run. We're going to push finish 3 input, and then we can do the same thing on the trace screen. So finish 3 input. There's the coolant. Now let's close the door and let's hit cycle start. And one thing to note, it says 2.498 on that diameter. On this machine and on every Mazak that I've come across, the wear shows up in the geometry when you're running the part. Some people found that annoying, but it's a nature of the Mazak. You can actually see there's a wear going on because it does adjust the geometry. All right, and we are done. And if we check it, check the size, if we like it, or we can rerun it again. But that's how to rerun a finished pass using Mazatrol. So we are done with the part. Blow it off. And that's our finished part.
Good.
If you like this video, please give it a thumbs up and subscribe. Also push the bell notification to be notified when we get new videos coming out. Thanks and keep watching.